Okay, it says you will now consider a method that can be generalized for all values of q. Consider this function. Show that x f dash of x equals this. Okay, so part C. F of x is equal to 1 plus x squared plus all the way to x of n, or x to the n. So show that x times f dash of x is this. So let's just get f dash of x. F dash of x is equal to, that becomes 0. This is 1 plus 2x plus 3x squared plus 4x cubed plus dot 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 plus n x to the n minus 1. Okay, that's the derivative. Therefore, x f of x, sorry, f x f dash of x equals this times x, which is x, this times x, which is 2x squared, 3x cubed, 4x to the 4, etc. And then n x to the n minus 1 times x is just n x to the n, because n minus 1 plus 1 will give me the n. Okay, that's part C. Part D, I. It says, okay, we have f1x is x f dash of x. Fine. And consider the following family of functions. So this is just a kind of pattern. f2x, f2 of x is equal to x times f1 dash of x. f3 of x is x times f2 dash of x. Right, so this is kind of, they've just defined it as this. Fine. It says show that f2 x is equal to this. Okay, now we know f2 of x is equal to x times f1. Now just be careful with my ones and my dash. x1 f dash of x. So this is what f2 of x is defined as. It's x f1 dash of x. Now f1 of x is equal to this. Okay, so this is f1 of x. So f1 of x, f1 of x is equal to this, because it's defined as that. f1 of x is x times f dash of x. f1 of x is x times f dash of x, or this. So it's x plus 2x squared plus 3x cubed plus dot 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 plus nx to the n. Now, that's f1 of x. To get f2 of x, we need to get the derivative of this. So first, and then times it by x. So f1 dash of x, and again guys, it's only 2 marks, I feel is very harsh. Anyway, the derivative of this is 1 plus 4x plus 9x squared plus all the way to n squared x to the n minus 1, because we multiply by n squared, and subtract 1 from the power. Okay, and this, guys, can be written as, it can be written as 1 squared plus 2 squared x plus 3 squared x cubed all the way to n squared. Sorry, that should be x squared. Hang on. That is 3 squared x squared oops, 3 squared x squared all the way to n squared x to the n minus 1. Okay, and to get f1 of x, sorry, to get f2 of x, we need to multiply this by x. So x times f1 dash of x is this times x, which is 1 squared x plus 2 squared x squared plus 3 squared x cubed plus plus n squared x to the n, because again when I multiply this by x, minus 1 plus 1 just gives me x to the n. Therefore f 2 of x is equal to the sum of, well, from I equals 1 to n of I squared, that's going to give me my 1 squared plus 2 squared plus 3 squared plus 4 squared up to n squared, times x to the I, that gives me x to the power of 1, x to the power of 2, x to the power of 3, x to the power of 4. So we have shown it there, and again only 2 marks. Okay, I'll stop there guys, and I'll do this proof by induction in the next video.